welcome everybody to the second meeting of the series in Quantum Mobile Network seminars. So I hope you, the participant, had fun and enjoyed reviewing the preliminary literature that we provided via the shared Zotero group. Today, our task is to form the groups that will deal with the presentations across the next few weeks, and also discuss a couple of procedure details, and then simply this, and also answer some questions if you have some regarding the technical content from last week. So maybe we could start from this actually. So does anybody have questions on what was introduced last week, especially since Professor Stefanov is here? Could be a good occasion for you to ask if you have questions regarding the quantum part. If you have also questions regarding the networking part, also I see here we have several advisors connected, so they will be happy to support you, and myself as well. So anybody? Some doubts on the content?
Hi, everybody.
Hi.
Can I have a questions about the last lessons?
Sure. Can you just say your name and your university?
Okay. Hi. My name is Giuseppe Verducci. I'm from University of Reggio Calabria, and I have a questions about when you talk about the properties, and you say that it appears when we saw that, but the other side, we know that it exists for the analysis equations, or for I would say a technical instrument that can reveal it.
I guess this is a question. So thank you for your question. I guess this is a question for Professor Stefan. It's about the observation, or what it means to observe something, right? If I understand correctly.
So okay, so you have, let's say, 2 points. One is almost philosophical, the other one is practical. So as the quantum mechanics is built, so there are some axioms or rules. And it says, okay, if you have a given quantum state and you measure it onto a specific basis, so because the quantum states are essentially vector in a Hilbert space, in a vector space, then you project the vector onto one of the vector of the basis, which is given by the instrument, the measurement device, and then the projection of the vector. The projection of the vector onto this basis gives you the probability to get a given output. So it's a well-defined rule which describes the measurements and tell you what are the possible output of the measurements which are given by your measurement device, and what are the probability to have a specific output. Okay. And it is like this. So for any purpose of calculation, you can use it like this. Then obviously, then the question comes more philosophical, as I mentioned, to say, what is the meaning of that? Because why there should be something special when you do a measurement? You know, what is the measurement device? Is it really the apparatus, or are we the measurement devices? So those are more fundamental questions on the, let's say, the reality of the wave function, and how does this really describe the nature, so to say. But this has no implication on the calculation. The way to calculate is given by those axioms of measurement of quantum mechanics. So essentially, you have a vector describing the states, another vector describing the state of the measurement device, and when you make the product of those two, the scalar product of the two vectors squared, then this gives you a probability. So this is, and you can apply this without thinking about the interpretation, and it's working well. So this kind of two aspects of it. So I don't know if that's answer your question.
Yeah, thank you.
Are there further questions from the participants?
It's more of an organizational one, if I may.
Yeah, sure. Also,
I just have been making notes on the previous lections, so I might just note it the wrong way, but you told that there will be some sort of like, I cannot call it a testing, but some sort of control with a deadline like in a week or so. But I only found the exercises which have deadlines like in 20 days, the closest one. Is that correct?
so let me just recap quickly how the procedure will be. So today we make the groups. Then next Friday we will not meet, so we give enough time to the first group to prepare their presentation. So to be fair, then in 2 Fridays we will start with the first presentation. So what will the presenters have to do? The presenters, of course, prepare the slides and give the presentation, and also prepare 3 questions related to the content of their presentation. Then these 3 questions are sent to me. I put these questions on the e-learning platform, and then the other students have to submit by Wednesday or the following week some answers to these questions. So to verify also the understanding, or if the people were actually attending actively to the seminars. Does it clarify your question?
Yes, thank you.
Okay. More questions?
Hi, I have a question.
Yes.
Thinking about, sorry, my name is Diego. I'm from UFPA in Brazil. I'm thinking about qubits and applications in quantum computation here. Is there a different way that we measure like Bell state from THZ states, or the same like apparatus? Because there are different applications from those states, and like in a physical way, is that different devices or the same device so that we measure Bell state from THZ state? And can you say something about this? I think
This is again for Professor Stefanov, yes.
So you mentioned GHZ states, which are 3-particle entangled states. So essentially, let's say, because you always measure, if you do, usually if you do a Bell test, or if you use entanglement between 2 particles which are separated, what you do is you measure each particle independently. So have a 1-particle measurement, and then you look at the classical, at the measured correlations, the correlation of the results. If you have 3 particles, that would be mainly the same. So you will have 3 times and single particle measurements, and then you will look at the correlation between your measurements, a kind of 3-fold correlations. So from the perspective of the measurement, it's always a single particle measurement. Of course, if you have 2 particles and then you make something like entanglement swapping, for instance, then one partner is receiving 2 particles, or a teleportation, for instance. So in the middle, you receive 2 particles, and then you have to do a so-called Bell measurement on those 2 particles, which is now a 2-particle measurement, which is different as a single particle measurement. But that's another configuration. So in general, of course, you could imagine having 3-particle measurements or n-particle measurements. But in practice, they are always more difficult, because such kind of Bell measurements just for 2 particles means to project the 2 particles onto the Bell basis, which, for instance, if you think of light and photons and you have only linear optic, you only mirror and dancers and stuff like this, you cannot do in principle. So such general Bell projection. Okay, did that answer?
yes. This was what I was looking for. Thank you.
Okay, let's see if there are other questions from the students. Okay, so if not, of course, feel free to interrupt me in the following minutes if you have any doubts that come to your mind later on.
Maybe just to add, also you can always send emails either to us or your advisor. I mean, ask also outside of this hour now.
For sure, yes, we have. So Ilias also has a function to send direct messages to everybody in the course. You can click on members in the platform, and then you can directly contact the people, or you can also post your question on the Ilias forum. If you're not sure to who to address this question, then you can just post it there, and then we will answer directly there. Okay, so regarding some other organizational updates, you might have noticed I sent some Gmail invitations to this seminar. So this is how Gmail works. So basically there is an event is scheduled, repeated every week. So you have received probably 4 emails. So one in which it's scheduled, the whole event, repeated until May 26th. And then next week we will not meet. And then we also skip 2 seminars, 2 Fridays during Easter holiday. So this means that you received 1 email to get invited for the recurrent event, and then 3 emails of cancellation of the specific dates in which we will not be attending. So if you just click if you want to attend, that's already helps me to organize. So that's also on the organization. I might as well just send a reminder email every day before the seminar, like in the Friday morning, just to help you remember that we will meet on the 3 p.m. Then, yes, so let's move on to the group formation. So first of all, something I would like to do also very quickly, because we have a lot of participants today. So last time we had the advisors introduce themselves. So now I would like every student to do a very flash introduction of yourself. So I would like you to say your name, your affiliation, basically the university and the country, and if you're a master student or a bachelor student or a PhD student or something else, I don't know. And what is your study, your degree, what you are studying, and possibly one research topic or something that interests you scientifically, let's say, or as a subject of what you're studying. Okay, so we could do this in order. So we could start from, let's see. So also this depends if, because I see some guests. So let's see. Okay, so the first one is Alice. You could introduce yourself.
Yes, can you hear me?
Yes, we can also do, if everybody agrees with this, all the students agree with this, a camera on. Depends. I don't want to.
Yes, sure. Give me a second because my laptop camera doesn't work. I have to.
You don't have to. You don't have to. It's just to see our.
Yeah, it should be fine. I just have to plug an external camera.
Good. All right.
Oh, wow. Okay, this works. All right. Hi, everyone. I'm Alice. I'm an informatic bachelor student from the University of Bern. Previously, I studied biology as well. So I'm also quite interested in biology. And sorry. And for topics, I don't, I'm quite interested in the topic in general. I said I was, for the seminar, I said that I was especially interested in performance of quantum networks. So the subject was capacity delay buffering, because I'm curious about it. Yes, that's about it.
Okay, thank you. So we can move on to André Nogueira. Sorry if I butchered the pronunciation, but
it's correct.
Thank you.
Yeah, my camera is on.
Yeah, sure.
Yeah. Hi everyone. I'm André Nogueira from University of São Paulo in Brazil. And I am a computer science undergraduate student. Last year, I started undergraduate research in quantum computing. So I have already studied the basics, and now I'm studying the communication part.
Okay, thank you. We can move on to, let's see, Bruno Martins.
Hello, everyone. I'm sorry, Professor, I can't turn my camera on right now.
It's okay, no problem.
Okay, hello, everyone. My name is Bruno. I'm a senior undergrad student at University of Pará. I study computer engineering, and my current research interest is distributed machine learning, but I have a solid basis in communications, both because of my research group and because the faculty members of my university are kind of familiar with telecommunications in general. That's all.
Thank you so much for your introduction. We can move on to Diego Abreu.
Hi, everyone. My name is Diego Abreu. I'm from Federal University of Pará in Brazil. I'm current PhD student under Antonio Belém advisor. I'm interested in quantum networking, but also interested in other topics I put there that I'm missing in simulations, because I already use quite a bit QSP and other frameworks there. I did my master's degree in machine learning, but now I'm changing the subject to quantum networking. So also new to the whole quantum managed idea. I'm very interested into knowing what are the prospects in research in this area. Thank you.
Nice, thank you so much. We can move on to Felipe Bastos.
Hello, everyone. I am Felipe Bastos. I am from the Federal University of Pará in Brazil, and I am in the process of finishing my master's degree and beginning the PhD. And my research focuses on simulation and the application of AI models in the physical layers of 5G networks.
Okay, thank you. Let's move on to Giuseppe Verducci.
Okay. Hi, everyone. Did you see me? Okay. Hi, I'm Giuseppe Verducci, and I'm from Miserani University of Reggio Calabria from Italy. And I have a bachelor degree in information engineering, and I'm pursuing my master's degrees in information technology and telecommunication systems. My studies focus in particular in subjects like network access network, mobile network, and in particular in routing protocol on various type of network, of course. Routing is my routing protocol is my most important thing in my studies, and so it's like for the topic of the seminar. That's all, and thank you.
Thank you, Giuseppe. Let's move on to Mateus Brito.
Can you see me?
Yeah.
Hello, everyone. I am Mateus Brito. I have a bachelor degree in engineering computing in Belém, Pará, Brazil. And I'm also from the University of Federal University of Pará, and I'm pursuing the master's degree in urban mobility. And also, as Bruno Martins, I am in the research group with computer networks and communications, and I'm looking forward to know better about the quantum networks. That's all.
Thank you, Mateus. Let's move on to Minrui Xu.
Morning, everyone. I'm Minrui Xu from Nanyang Technology University. My research interest is mobile quantum computing, and I am a PhD student. And yeah, that's all. Thank you. Hope I learned from you a lot.
Thank you. Okay, now let's see who is the next. Now the next one is Neville Aftermauer.
Hello everyone, my name is Neville Aftermauer. I'm a bachelor student from University of Bern, and mostly my interests are mobile ad hoc networks and any kind of mobile networks, and especially layer 1, layer 2, layer 3 of the OOC model.
Thank you, Neville. Let's move on to Alexander Pertsiuk.
Okay. Sorry. Can you see me?
Yes.
So my name is Alexander Pertsiuk. I'm pursuing a master's degree at University of Bern, and I did my bachelor's in network engineering and internet technologies. So yeah, I'm quite interested from a cybersecurity perspective in this seminar.
Thank you. Nice topic. The cybersecurity also a big topic in this seminar. Okay, now let's move on to Pratik Mantri.
Hi everyone. I'm a PhD student in computer science at UMass, working with Professor Don Dowsley. My research interests are quantum network architecture and information theory.
Thank you so much. Now it's a turn of Rafia Mosaheb.
Hello, my name is Rafia. Currently, I'm a PhD student at University of Luxembourg in Security and Trust Department in APSIA Group, and I'm studying electronic voting. But before, I was studying quantum computing, quantum cryptography, and quantum algorithms at University of Tartu. So my research is not directly related to quantum mobile network, but I wanted to learn more. That's why I'm here.
Thank you so much. And finally, Ufuk Dede.
Hello, everybody. My name is Ufuk. I'm from Turkey, and I'm studying at the University of Bern right now, doing my master's with a specialization in distributed systems. I'm particularly interested in blockchain technology, and right now working for a blockchain company in Singapore remotely. So the reason I selected this class was because I want to learn about quantum computing better, and also communication part is quite important in distributed systems. And also I am interested in gossip protocols in particular in this seminar. So yeah, that's it.
Thank you so much. So did I forget anybody of the participants? I mean, or if there is any of the auditors that want to introduce themselves, also feel free, but it's not, you don't have to. All right, so now that everybody knows a little bit the background from basically everybody else in the seminar, so advisors, students, we can move on to the more technical part, which is forming the groups. So I will share my screen so you could see the spreadsheet that we disseminated. So you should be able to see my screen. So if you haven't expressed your preference so far, so you can find the link in the Ilias, but I also send it in the chat for your convenience. You have edit rights, so you can no need to ask for permission or password. So how to see this spreadsheet? We have each row with a certain group, and you express the preference where you indicate you rank the topics from the one you prefer the most to the one you prefer the least. So 1 most preferred, 8 least preferred. So if you haven't done it so far, please do it. And then here on the second part of the spreadsheet, in this area here, you can see the crosses which indicate to which group you have been assigned. So what was the criteria? What criteria did I follow to form these groups? Basically, for increasing letter of column, this is the arrival. So each person just expressed their preference incrementally, and then I just assigned, in order of arrival according to the preference. But of course, we have to make sure that groups are heterogeneous in terms of affiliation university. So for example, if the first student expressed preference 1 for topic 2, so of course this is has been the first one to express it, so it has it. But if another person from the same university wants the same group, then this is a second priority. So I think we can ask, so Minrei Xu, you will present, right? You will participate in the presentation. It's not only listening, right?
Yes.
Okay, so
I hope, yeah.
I will put
Thanks a
it
lot.
in green then. Okay.
Thank you.
And about Jakob is not here, so I can ask him offline. So yeah, if you need to, for those who haven't done it so far, you need to review the literature and then express this, your preference. So let's see, does everybody is fine with this arrangement, this preliminary arrangement, or would you propose some changes or some swapping? Just let me know. Okay, so a few people, of course, who enrolled did not express the preference. So we can do in this way. So the groups are basically formed. So this will be the groups. And then when we receive late requests for joining the groups, then we will ask the groups whether they want to accept the late arrival. Because obviously, if you start preparing a presentation and then a person wants to join 3 days before, that's not entirely fair. So it will depend on the group if they want to have the person join at a later stage. So yes, so any questions on this? Good. So for today, I think there is not so much more to discuss. What we will do now, after, let's say, the official end of the session, I will create some breakout rooms in the Zoom meeting, so that I will create 8 breakout rooms. So the students that are assigned to each of these groups, they can join and basically interact, get to know each other, exchange contacts, and so on. So for those students who are now in the call but have not expressed their preference, can they provide on the fly some group they would like to join, or they prefer taking their time to review the literature and then tell me in 1 or 2 days maximum?
Professor, I'm not, how can I say, set my preference, but I would like to join the group of Bruno Martins, if that's okay for him.
Bruno Martins is the Age of Information?
Yes.
This one? Yes, group 7. Yeah, this is possible. Actually, it's good because it's the last group with only 1 person. So I will just write. You are UFPA?
Yes.
Okay, so I guess, yeah, you don't need to, I can just put an X here. Good.
Thank
Anybody
you.
else?
Yes, Professor, it's Alexander Petsu.
Yes.
Would like to join the group of routing in quantum mobile networks, if that is still possible.
Let's see, 1 second. Okay, let's see. You said routing?
Yes, yes.
Routing might be possible. Let's see, routing. Yes. Okay. Actually, let me just see a second, because here we see routing has already 2 different universities, Reggio Calabria and UFPA, whereas group 7, it's Mateus and Bruno, which are both Brazilians, I mean, both from UFPA. So technically, would it be also okay for you joining the Age of Information? Because they have different, yes, you see, because that's already heterogeneous, while the group 7 is still both UFPA, so.
Okay, not a problem. I'm just a little bit more experienced with routing, but anyways.
Yes. Any other expression of interest now from the students? I think we have, let me scan quickly. I think, okay, Rafia, Mateus, Andre Nogueira did express the preference? No. Do you have already an idea? Would you like to wait a bit more, Andre?
Yeah, I have expressed my preference. I'm already in group 5, I think. Yeah.
You are
André Ribeiro.
Okay.
Yeah.
There's
Sorry.
the multiple surname issue from.
Yeah, I will rename my name here.
That was
so the same one. I'm sorry.
No problem. It's just it was tough for me doing an alphabetical sorting of the Brazilian students, because you never know where the surname starts. But anyway, so who is left there? Pratik.
I haven't yet decided, but I have a preference for routing.
Okay, I think that's fine. More people that we did not consider so far from those connected. Alice is there. No, okay, so at least for those connected, we should be all set. And then for those who haven't expressed so far, then also the advisor, you could shake them a bit so they can join this. I will also send a recap email just to make sure everybody is aware. All right, so for me, till now it's all. So for minor communication, we just take it offline with emails. So what we do now is that we could end formally the meeting, and then I'll create the breakout rooms where the students of the relative groups, they can interact. Something I would like to come out from this meeting is the selection of some sort of spokesperson, like some representative or some team coordinator, team lead, or you know what I mean. So you can interact, and it's better I don't impose a collaboration tool. It's better I leave you free to prefer whatever platform you wish to use. And then after you select who wants to be somehow the team lead, just make, instead of the X in this grid, just you can put another symbol, like a bold X or a Y or a lead, something to indicate that you wish to be somehow the team lead of the group. Thank you so much for coming here, and we keep going with the breakout rooms.